So as we are working through this chain rule, the questions can get increasingly more difficult, but most of the time, the rule is going to be the same. It's just the algebra piece of it you want to think about. So we did a couple of examples in our last video. Let's do a couple more where maybe the difficulty level increases. Let's say I want to find dy dx, so that's the derivative of y with respect to x, of, let's say y equals the square root of x squared plus 2. So the first thing that I need to do is I need to identify what is my outside function, and then what does that make u? And the outside function really is what is f of u? So if I were to replace something in this function with a u, I would probably replace this x squared plus 2, making my f of u that function. U then would have to be x squared plus 2. So I found my f of u and my u. If I were to plug u back into here, I would get y. So that's how this works, is we are decomposing this function. Now we're ready to apply this rule. We're going to take the derivative of the outside function. Remember, this is the same thing as u to the 1/2. So this is the algebra piece of it. So dy dx equals, well, when I take the derivative of the outside, I'm going to have 1/2, and I'm just going to put parentheses here, to the negative 1/2. Remember, the power rule states you multiply by the exponent and you subtract 1. 1/2 minus 1 is negative 1/2. Now, don't be lame. Keep the inside the same. And then our last step here is to to multiply by the derivative of u. So I have 1/2 times x squared plus 2 to the negative 1/2. That is the derivative of the outside. Keep the inside the same. Now multiply by the derivative of the inside. The derivative of u is 2x. So the derivative of u is 2x. Now it's a matter of simplifying. So now it's just a matter of simplifying. So this is going to equal 1/2 times 2x times x squared plus 2. That just turns into x. And I can drop that down into the denominator because it's negative. And then I turned it back into a square root because a 1/2 is a square root. So we identified what our outside function was, and then we took the derivative of the outside function. We weren't lame, we kept the inside the same, and then we multiplied by the derivative of the inside. And this one took a little bit more algebra, but it wasn't actually any more challenging. Let's try another one. Let's say we want to find dy dx of f of x equals, I don't know, let's do the cubed root of x plus 2 squared. Oh man, that's ugly. That is ugly. We don't really like that very much. But we could rewrite that using rational exponents, and it makes it a little bit better. This is going to be x plus 2 to the power of 2/3. Rational exponents. Rational exponents, because this is squared and this is a cubed root, it becomes 2/3. Now I can identify my outside function. My f of u is u to the 2/3, which makes my u x plus 2. Okay, now I can apply my rule. I want to take the derivative of the outside function. The derivative of the outside function, I'm going to multiply by 2/3, and then I have to subtract 1. So the derivative here, dy dx, equals, I'm going to multiply by 2/3. I'm kind of leaving my skeleton here. I'll fill that in a moment. 2/3 minus 1. That's what's going to go up here. 2/3 minus 1 is negative 1/3. Just so you know, that's negative 1/3. I'm not going to be lame. I'm going to keep my inside the same. And then I'm going to multiply by the derivative of the inside, which is 1. U prime here is 1. Okay, let's simplify now. I have 2/3. This is going to be x plus 2 to the negative 1/3. Times 1 is just that. This negative 1/3, I can drop it down into the denominator, and a 1/3 is the same thing as a cubed root. 2 stays in your numerator. And then you'd have 3 times the cubed root of x plus 2. So what we did here, we identified the outside function. In order to identify the outside function, we did have to do a little bit of rewriting. That's okay. So we did a little bit of rewriting, and then we figured out what u was. We took the derivative of the outside function. Which was 2/3 u to the negative 1/3, which is where this comes from, 2/3, and then to the negative 1/3. We kept the inside the same. That x plus 2 went in for u. And then we multiplied by the derivative of the inside, and then we rewrote it. Now, one thing that I like to do, I like to just play around on Desmos. I like to see what these derivatives look like and analyze it. Let's go ahead and do that with this one. Let's just look at the derivatives of this function, and let's make sure that we got the correct derivative. So when I go to Desmos, I already have a Desmos open. I'm going to put our original. And I always put it in as f of x because that allows me to take a derivative in here. X plus 2 squared, and then to the 1/3. And yeah, there is a way to do that. Cubed root, it's going to be right here. So I could have went miscellaneous and then this root. And so I could have done cubed root. I could have typed it in like that. So there's our function. When I analyze this function, I know that the slope on this side of the function is negative. The slope here is negative. And actually, as it's getting closer and closer to this cusp, it's getting a little bit more steep. Right here, my slope is positive, which means that right here at that cusp, it's not differentiable. Right here at that cusp, we're going to have an asymptote. So let's take the derivative of this and see what that looks like. I should have negative slopes and then positive slopes and then an asymptote. Look at that. All of these slopes are on the negative side of the y-axis. These are all negative. These are all positive. And right there at that cusp, x equals negative 2, I do have an asymptote because it's not differentiable at the cusp. It's not differentiable because the slopes take a jump. We go from negative slopes to positive slopes. It just doesn't work that way. There we go. So this is our derivative function. Let's go ahead and turn this one off. Let's go ahead and turn our asymptote off. Let's plug in what we solved for and just make sure that we got the same thing. So what we solved for was 2 over 3 times the cube root of x plus 2. And what you'll see is that our derivative falls directly on that same line. And so we know that we solved for our derivative correctly.